the question given to us is that we have to find the number of acute angle triangle such that the sides are consecutive integers and the perimeter of the triangle is less than 100. So before we proceed with the solution, let us quickly recap the important findings that we did in the theory part, which will be helpful in solving these questions. We know that if A, B, C are the sides of triangle, and let us assume that C being the largest side, then for triangle to be possible, the sum of any two sides must be greater than the third side. That is, C should be less than A plus B. Also, the difference between the any two sides must be less than the third side. So this is the fundamental things for triangle, for possibility of triangle. Apart from that, we also studied that for acute, right, or obtuse triangle, if the square, sum of the square of the two smaller sides is equal to the square of the larger side, then it's a right angle triangle. But if the sum of the two smaller side is sum of the square of the two smaller side is greater than the third side, the square of the third side, then it's an acute triangle. And if the sum is less than the square of the third side, then it's an obtuse triangle. So this was a quick recap of the theory. Now let's come back to the questions. So now it says that the sides have to be consecutive integers. Let us assume that the sides to be n minus 1, n, and n plus 1. So these are the three consecutive numbers where n is an integer. Now applying these concepts and the constraint given in the question, we see that the sum of these three sides must be less than 100. So if I add these three sides, it should be n minus 1 plus n plus of 1 should be less than 100. Or for the simplification, I can get that 3n should be less than 102, or n should be less than 34. So the maximum value of n is 33, or I can say that n has to be less than equal to 33. So this is the first information we got something about the value of n. Also, let us apply these two logic. Here n plus 1 is the largest side of the triangle. So with this information, I can say that n plus 1 must be less than n plus of n minus 1, which gives me n should be greater than 2. So this is also one of the condition on n. Okay, so using these two constraints over n, we have to eliminate all those values of n for which the triangle is not optimal. Now let us apply the other condition, that for acute angle triangle, the largest side, the square of the largest side, which is n plus 1 here, should be less than the sum of the squares of the other two sides, which is n square plus n minus 1 squares. So let me bring everything from right hand side to the left hand side. So we are left with n plus 1 whole square minus n square minus of n minus 1 whole square is less than 0. For the simplification, we get, if I take these two together, so it will be a square minus b square, so it will be a minus b into a plus b, which comes out to be 2n into 2 minus of n square should be less than 0, or on a further simplification, I can get that n into 4 minus n should be less than 0. So this is the constraint for triangle to be an acute angle triangle. So now let us take up the range of n. We have the range of n as 33 should be greater than 2 and should be less than equal to 33. So if you put n is equal to 3, the smallest value which we can put, we find that the value or the value of this expression is positive. Hence, for n is equal to 3, the triangle is not acute. Similarly, for n is equal to 4, the value will be 0. Again, the triangle is not acute. For n is equal to 5 and 5 onwards, we will find that the value of the expression will always be negative. We can see that this factor, if n is greater than 5 or greater than 5, then this factor will be negative always. So this expression will be satisfied. So we found that for all the value of n greater than equal to 5 and less than equal to 33, the given triangles will always be acute angle triangles. So the number of triangles so found will be 33 minus 4. I am taking 4 here because I am discarding this value, and for n is equal to 1 and 2. So the number of required acute triangle is 29.